Now for some this would be obvious, in which case you can skip this section. For others maybe not so obvious. Consider the symbol that you quite often see it when they talk about loans and things. You know, suppose we had that. Now it's 5%. It is understood that that is 5 over 100. Now the thing is, it also means we have 5 times 1 over 100. You know, it's a bit like if we have, say for example, 5 meters. This is the count. This is what you're counting. Now, this is a unit of measurement. The word unity means 1. So, in fact, we have 5 of 1 meter. This is an important word. That is the unit of measurement. In mathematics, of means multiply. Compare that to this. 5 of 1 over 100, so that in fact is a unit of measurement, or a part of. What we normally have is 5, I'll write it like that. Suppose we had £1,000 in our account, then there's a multiply there as well. It's 5 of 100th part of £1,000. This is what it means. That is, it's a descriptive sort of unit of measurement of that. It's a part of that. It's splitting it up. You have to really understand that is the case, in which it must mean that this thing here is exactly the same as times 1 over 100. So whenever you see that, think of that. So we had 5% of £1,000, 5 times 1 over 100 times £1,000. Really need to make sure you fully understand that. Right, the difference between simple interest and compound interest. Simple interest, you always add the same amount. Compound, what you add grows. It gets greater. Okay, so let's take a closer look at that. Suppose we had there. Suppose we had a deposit of £1,000. Picked on £1,000 because it's an easy number to calculate. And the interest, oh by the way, that's normally called the principal sum, the amount you first put in, principal sum. And we're going to set the interest at, I'll put INT for interest, 5% for each year. Now the calculation cycle for this, to make things simpler, I'm going to call a year, right? A year. Now 5%, so what's 5% of that? 5 over 100 times £1,000. Cross off that not, cross off that not. So we end up with 5 over 1 times £10. I mentioned this on another video, an earlier video. Right, so that is equal to £50. Okay, so what we would be adding is £50. So at the end of the first year, we have £1,000 plus £50. That takes it up to 1050. End of the second year, we add another £50. So that would take it up to 1100. See the way it goes? It always adds that. Now let's come over here. The end of the first year, or the first calculation cycle is a better way of wording it, would still come as £50. Alright, so that is plus £50. So that would then change the account such that you have 1050 like that. That hasn't changed. Now we apply our 5% to this figure here, so this will be greater than that. So we have 5 over 100 times the new figure here, 1050. Cross off that, gets rid of that. That one means the decimal point goes in there. So we have 5 times 10.5. 5 5s are 25, carry the 2, 5 10s are 50, 52. So this one, add £52.50. See, this has grown. That's the difference between compound interest and simple interest. In reality, you know, I worked it out at the end of the year. In reality, it would be calculated monthly normally. It can be done quarterly, but normal accounts, it is calculated monthly. That makes the thing very, very different. It's a different animal entirely. I was going to use Excel, but I think that might be distracting you from what we're doing, and may not be a good thing to do. So I'm going to try and do this by hand. Suppose the principal sum, the amount you put in at the beginning, is equal to £1,000. And suppose the interest, I'll just put INT, I can't be bothered to write the whole word, is equal to 5% per year. Per year. Okay, let's have a look here. This is simple. Simple interest, INT for interest. And we have initially, we put in £1,000. Now look, 5% of 1,000. These are numbers that work quite nicely. 5 is 5 over 100, if you remember, of 1,000. 2, 3, cross off that, cross off that, cross off that, cross off that. So you end up with 5 over 1. There's that thing again, times 10, which equals 50. Okay, so the interest plus 50 is equal to £1,050. That's at the end of the first calculation cycle, end of year. Now in reality, if you have an account, it's calculated monthly and usually it's compound interest. But I can virtually guarantee you'll be given a simple interest question. You may also be given a compound one, but anyway. So that's 1,050. So that's at the end of year 1. End of year 2, we have our 1,050, that value there, plus 50 is equal to 1,100. Year 3, we have our 1100 plus the 50 equals 1150. See the way it's going? It goes up the same amount each time. Right, that is simple interest. So I'm working this out at a yearly calculation cycle, 1 year. Like I say, monthly it is done differently. Right, so this now is compound interest. INT, I can't be bothered to write the whole word. Interest. End of the year, we have our £1,000 plus the 50 is the same as the other one at the start, at the first calculation cycle. So it is £1,050. That's end of year 1. End of year 2, we have 1050, same as that, but this is the thing, that changes. It's 5% of this, not 5% of that. Simple interest is 5% of the initial amount, as long as you don't put anything else in the account. 5% of that is this. 5% of what is in the account is your compound, so 5% of that. Let's do a quick calculation. 1050 times 5%, 5 over 100, cross off that, so the decimal point goes there when we get rid of that. So it is 5 times 10.5, 5 5s at 25, carry the 2, 50, 52, 20, 50, 52, 50, so 52.50 equals 0.50, and we end up with the 2 there. 5 plus 5 is 10, 1, 1. See, the amount we add in has increased. The amount we add in stays the same. So the next year we have this bit here, 1102.50, and we add to that 5% of this. See, so this amount here would be greater than that. That's how these interests work. Let's take this up a notch. Suppose we calculate, instead of once a year, do it monthly. Per month, the end of the month. Now that is a different animal. It brings into play all sorts of different things. This is why in mathematics stuff cross over. You cannot isolate things a lot of the time. Some other bits come in that you have to use. Just to lightly touch on the use of brackets, because we'll be using those. Suppose I have 2 times 8. Well, we know the answer there is 16. 2 8s is 16. Let me split the 8 into 3 put with 5. It is still 8. Now if I want 2 times that, what I end up with, this here, is the same as 3 plus 5. There's one of them, and there's another one. Now if I were to add those up, 3 plus 3 is 6. There's the plus. 5 plus 5 is 10. Now look at what happens here. 2, 3 put with 5 is 2 times 8. They know there's a multiply there, they just don't bother to write it. Okay? It's accepted, that's the way it is. 3, multiply that by 2 and you get the 6. See? 2 multiply the 3, gives you the 6. 2 multiply the 5, and you get the 10. So what it amounts to is everything inside the bracket is multiplied by 2. If I have 2 times minus 4 plus 7, everything inside the bracket is multiplied by 2. 2 lots of 4 is 8, but it's negative. That is positive. When the signs are different, the result is negative. Now we've got here positive, positive, so the answer is positive. 2 lots of 7 is 14. You see? It's the way it works. 3 times minus 5 plus 2. Positive times negative is negative. 3 5s are 15. There are positive times positive is positive. 3 times 2 is 6. See the way it works? Now, if you've done it that way, you can also do it in reverse. But I don't want to go too much into detail on this because it's another topic on its own. What I'm suggesting is you just accept that this is the way that things are with what I'm about to show you. Alright, now we're going to have, I'm not actually doing it at the moment, we're going to have a bracket. It's going to be a number in front, whatever it is. Not that looks like 0. Let's not make the matter worse, shall we? Some number in front. I'm going to use P for principal sum. It's what you initially put in. It's going to be things in here, and the calculation cycle count. The count goes up there. It's raised to a power. You know, like 2 raised to the power 4. That's raised to a power. What that is a power, right? Okay, so we have that. The power that it's raised to. Now we had 5%, which we know is 5 over 100, as previously explained. Now the thing is, the 5%, if it is per year, and is calculated, so the calculation cycle is monthly. There are 12 months in 1 year. Well, we know that, but you have the bracket. The calculation cycle, you have the count of years, multiply that by, now if I call, suppose it's a monthly one, it's calculated per month, then that would be the count of years, times 12, because there will be a calculation each month. So it is 12 months multiplied by the years, gives you the total calculation cycle is that. Very important. That also has an effect on the percentage. So the 5% is over the whole year, but we're calculating it monthly. So if we spread that out over each month, by the time we finish and added them all up, it's the same as the year's percent. All right, so that is split or spread. I'll use the word split. It's split over the year. So what we have is 5 over 100, and we split it over the year if it's calculated monthly. That's monthly. What if it's quarterly? That's 4 per year. Well, we use 5 over 100 divided by 4. Now that will also affect this thing up here. You'll see what I mean, right? This is just to get you thinking the right sort of way. It will become clear, I will do a number of examples and it will slowly click. Okay, again, I'm going to stick with the 5%, which is exactly the same as 5 over 100. Bracket. Now look, remember the structure. And we're going to use as a principal sum, what shall we use? Let's stick with the £1,000, shall we? So the principal sum is £1,000. Right, the formulae, principal 1 plus the percentage as it's split. I'll just do that. All right, times n. You'll see what that becomes. Now, 1, always 1 plus what you increase by. Now, if we got 5% and we're doing it per month, all right, so it's worked out each month, we have the count of years times the count of months. What we have here, in this case, it's 5%, and it's divided by the 12. All right, so if I were to expand on that, 1,001 plus, now look, 5% divided by 12 is 5 over 100 divided by 12 is 5 over 100 multiplied by 1 over 12 is 5 over 1200. So here we have 5 over 1200. How many years shall we do? How many years? Let's say the years are 20. Right? So we're doing it over 20 years. Number of years, 20. There are 12 months in a year, so it's times 12. Now look, that 12 there, same as that 12 there. This is the count of years. Alright, so let's get rid of this and call up my faithful calculator. Let's work this out, shall we? We have 1,000, that's this bit here, times a bracket. Now calculator, some you don't have to put the times in. I'm making sure it works, I'm putting the times in. It's not normally written, the times there. 1 plus, we have 5 over 1200. Let's use the fraction setting. 5 denominator, 1200. Come out of the fraction, close the bracket. Open a bracket, you've got to close it. Now it's raised to a power, which is this one here, and it's raised to the power of 20 times 12. And that gives me this value here. Okay, so this equals, and I should have looked at it, 2712, 2712, decimal point, rounding, 1, 2. The cutoff is between the 4 and the 0. The 0 is less than 5, so we do not round up the 4, so it's 64. Okay, that's that one. Let's do a different number of years. Equals, I don't know, let's go for 30, shall we? 30 years. So you have the amount that you initially put into the account. You don't add anything to it, you don't deposit anything more, because it makes it more complicated if you do that. There's the 1, here's the percent, 5, remember it's over 12, no it isn't, it's over 100, but then because it's every month, we have to multiply that by 12. Let me extend this. Yeah. And we said 30 years. There's the 30 years times the 12. That gives me a total count of the calculation cycles. 30 times 12. 30 times 12. 10 times 12 is 120. 3 12s are 36. 6, 3, 5. 156. So that is 156. But I'm not going to put that in. I'm going to put it in as per this. So let's have a look here. Clear that lot. We have a principal sum, 1000. Multiply that by what's in the bracket, 1 plus 1 plus. And I'll put it in as per this. Using fraction format, we have 5. Come down, we have 100. That's 5%, but then we divide it by the 12, which is multiplied by 12 here. 12. Come out of the fraction, close your bracket. There's your bracket there. All raised to 30 times 12. And that is wrong. Let's do it again. Let's do it again. 1, 1, 2, 3 times bracket 1 plus. Use fraction 5 over, that's 1200. Come out of the fraction, close the bracket. You must always close the bracket. Raise to the power of 30 times 12. Come out of that, equals, that's better, that's better, 4467, 4467 pounds and 74. There's the cut-off point. To the right is 4, which is less than 5, so we don't round that up. 74.74. Right? Repetition helps you learn. Let's do another one. Right, to emphasize a point, instead of doing it monthly, let's do it quarterly. So there are 4 divisions in 1 year, 4 calculations in 1 year. Alright, so we have a principal sum, the amount we originally put in, 1 plus 5%, which is 5 over 100, but because we're doing 4 calculations, we split it by that. And up here, how many years shall we do it for? Years. Let's do it for 13, just to be different. Right? So it's 13 times 4. That number there, same as that number there. 5 over 100 is your percent. Let's do this, shall we? Let's do this. Where were we? Clear that lot. So we have our 1000 times 1. Now you can play around with this so you could just get one number, but I'm not going to. I'm going to continue like this because the structure is important. Fraction 5. Come down here. We have 100 times 4. Come out of the fraction. Close the bracket. Raised to the power of 13 times 4. 13 times 4. Come out of that and we get this value here. So in fact it's 1907. The decimals are 8 and 3. The cutoff is between the 3 and the 8. 8 is greater than or equal to 5. That's the trick. If it's greater than or equal to 5, this number here, this digit is rounded up, so it becomes 0.84. Let's do another one. Suppose we do it 3 calculations a year. Okay, 3 calculations a year. There's your 1,000, 1 plus 5 over the 100, 5%, 3 calculations per year. And how many years? Let's still stick with the 13 times 3, because that's the calculation cycle. 3 times 13, 13 years, 3 per year, so it's 3 times 13 calculation cycles, and that will equal, clear that lot, there's your principal sum, multiply that by 1, always have 1, plus the fraction, 5, come downstairs, we have 100 times the 3, come out of the fraction, close the bracket, raised to the power of 13 times 3, come out of that, and we get this value here, 1905. 1905, and decimals are 1, 2. The cutoff is between the 0 and the 6. 6 fits 5 or greater, so we round that upwards, so it becomes 0.31. Just for luck, let's do one more. Let's do a stupid one. Alright, this is a stupid one. You will not get one like this. Plus, there's your 5%. How many calculations shall we do it in a year? Oh, that's 1,000, that's going to be 100. Oh, dear, dear, dear. Did you spot that? Did you spot that? And now it's 5%. So easy to go wrong. Let's do 15 in a year. You will not get this. This is not realistic, all right? It's just showing you. So we're going to do it for 13 years, but 15 for each year, times 15. So this has a greater count of calculations than this one. This one is 3 per year, this one is 15 per year, and we'll see how different that is. It should be a lot greater. Equals, yes. Okay, clear that lot. Maybe let's see what we got here. We have our principal sum, 1, 2, 3, times the bracket. Always have the 1 plus the messed around percentage. Do it in fraction form. 5, come down 100. That's your percent. Times, there's 15 calculations in a year. Oh, 15. Come out of the fraction, close your bracket, raise to the power, and the power is 13. So it's 13 years, 15 calculations in 1 year. This is silly because you will not get this, all right? But it demonstrates what I want to do. 1913. Point. 7 cut-off points between the 7 and the 1. The 1 is less than 5, so we do not round up. The 7 is 47. The more calculations you have within a year, the greater this becomes. The greater this becomes. It tends towards a particular value, but I'm not going to, you know, the rate of growth tends to a particular value. I'm not going to go there here. But you can see how that works. Look, we had 4 calculations in the year, so there was the 4 there. 3 calculations in the year, so we had the 3 there. 15 calculations in the year, so we had the 15 there. This one is a joke. It's a joke. Do you understand? Practice. Fix this in your mind. As I say, the difference between simple interest and compound interest is that compound grows at a faster rate. Okay.